Good afternoon, everybody. Thanks for joining in our third installment of our knowledge bursts. And today, I think we have an outstanding topic today, and definitely, I'm personally excited to listen to this presentation, and hopefully, we'll have a really solid set of discussion points on the back end. But before I get going, I'd like to just kind of tee it up a bit because why I think is such an important topic is we're living through some very interesting times today in with regards to this whole notion of health passports or vaccine credentials in our ability to really push opening up our economies, particularly from the travel industries. But when you take a step back, what we're really talking about is a variation of our identity and really data about us. And what we truly understand is data about us, how we feel, how we think, what we buy, what we do is all very, very valuable to the point that companies really try to position themselves to own and control it. And when we take this in today's world and we're looking at ourselves from the standpoint of our online personas and our digital footprints and digital identities, at this point in time, we really don't own our own digital identities. Organizations define us by what we're buying, by what we post on our social media, by what we're browsing and searching for on the internet. And the younger you are, the more of your life is codified within these systems, to the point that they use this data to influence what we do and how we think, and even potentially how we behave. And we're really at this crucible moment from the perspective of transferring ownership and empowerment back to individuals and allowing us not only to own our physical identity, but also our digital footprint and our digital identity, which is so important for us to access the infrastructure necessary for everyday life, and quite frankly, so important for establishing a broader sense of equity across all social demographic groups. And so today, to kind of walk us through this topic and it's all its variation, we have our Chief Strategy Officer, Amber Hartley. Amber joined BurstIQ 4 years ago. We were talking this morning, and I was saying, wow, has it really been that long? And we've had a ton of fun together over the last 4 years and kind of shaping what we do at BurstIQ, but also really reaching out and trying to influence industry. And Amber has over 20 years of working partnerships and strategies within the biotech, high tech, and healthcare space. And she has a deep understanding of how all these industries interact with each other, what the challenges are, and she brought all that experience to BurstIQ. She's been a tremendous contributor to what we've done. Prior to joining BurstIQ, Amber ran the Innovation Center at Catholic Health Initiatives, which at the time was one of the largest health systems in the United States, and subsequently merged into a broader consortium of Common Spirit. She holds a Bachelor of Science in Animal Physiology and Neuroscience from the University of California in San Diego, and a master's degree in biotechnology from San Jose State University. So without further ado, I'm going to hand the floor over to Amber and let her kick us off for this next round of Knowledge Bursts.
Hey, thanks, Frank. And thank you so much for everybody joining us today. We really appreciate having you here. We're going to talk today about trusted data and how companies are using trusted data to build smarter products and more secure data networks. So this is such a timely topic, especially in light of all the news about several major security breaches this past year and all the challenges that we're seeing with vaccine distribution. But first, I want to take us back a couple of years to the aftermath of Cambridge Analytica, when many of these data privacy issues really kind of came to a head. Those events really uncovered some important issues around data privacy and control, and they highlighted how little visibility people really have into what companies are doing with their data. But I want to touch on kind of one thing in particular. I can't count the number of times I've heard a company say, well, you can trust that your data is safe because we store it on an encrypted database. Last month, Brian Jackson, our COO, did a really nice job of showing us why this strategy is problematic from a security perspective. But there's another problem with it, and that's that they're basically saying, well, you can trust the data because you can trust us. But what if you can't trust them? What if you don't even really know who they are? How can you trust the data if you have no way of trusting the entity that controls it? So there are a number of emerging technologies that are really designed to make it possible to trust data even when you have no way of trusting the source, or even if you don't know the source at all. Blockchain is certainly a part of that, but the ability for blockchain to enable trusted data really kind of depends on how it's implemented. So typically, data security is managed at a file or a database level, like you see here on the left. Sometimes blockchains are layered on top of that to manage who's allowed to access the database, but the data management itself, it's still pretty conventional. So what trusted data does is bring these security layers down to each individual data point so that the security is enforced no matter who controls it, no matter where the data goes, and no matter how it's combined with other data. The second thing that trusted data does is provide context. So if I'm going to trust a piece of data, I want to know that it's secure and hasn't been tampered with, but I also want to know more about it. So let's take a doctor's medical degree, for example. If you see that a doctor got their degree from Harvard, how do you know that that's actually really true? They could have just put that in. If a doctor just claimed they graduated from Harvard, you might want to see a secondary verification, like say from a credentialing company, in order to trust that that's actually true. But if that info came directly from Harvard, you might be more willing to trust it even without that independent verification. That verification, the source, the history, all of that is context. And that context is really important to understanding a piece of data and being able to trust it. So in other words, trusted data is data that understands itself. It has intelligence just built right into it. The last thing that trusted data does is package up all of that security and context in a way that allows that piece of data to become mobile. So trusted data can be shared and moved and even monetized without losing any of the security or context that gives it that trust. So there are a number of emerging standards like W3C, verified credential standards, that are really designed to provide a framework for building these trusted data packages. The net in all of this is that trusted data allows us to move from an environment where you're forced to trust the entity that controls the data into an environment where you can trust the data itself. And that's really important for a couple of reasons. The first is that trusted data brings intelligence into the data itself, like I was talking about. So as you're building these AI and deep learning models, that deep level of intelligence is super valuable. Not only do you know a piece of data and where it came from and how it's evolved over time and whether or not it's been verified. So let's say a certain type of data that seems to be updated or changed a little too often in kind of a weird way. That could actually mean that there's a problem with my workflow that's causing some data entry issue. But without that history or context of that piece of data, you'd never really know that that's an issue. It just wouldn't come up. The second reason that trusted data is so valuable is that it's really the backbone for how we enable these smart, trusted networks where really complex processes can be automated because you don't have to manually verify all of the data. That verification is built right in. So things like credentialing and rev cycle and contracting, they become a lot easier to manage with trusted data. So I want to dig into that intelligence piece a little further and talk about how trusted data really enables that. So if you do anything online, you have a social graph. Amazon knows how you are related to every product, every user, and every purchase. They know exactly what to suggest to you and exactly when to suggest it. Facebook and Google do the same thing. They know how you relate to every other person and every advertisement on the platform. So all of these are versions of social graphs, and every major tech company has a social graph about you. The problem is that social graphs have a pretty negative reputation since they've been used in a lot of really intrusive ways. But the underlying graph models and the graph theory that they're based on is actually really, really useful. So in the healthcare industry, graph models have enormous potential to do good. The shift towards value-based care has really pushed the industry to find better ways to optimize. And that means getting much deeper insights about their system and the people in their system. But in order to do that, the industry needs to combine medical data with all sorts of other data. So behavioral and social data, IoT, genomic data, environmental, on and on and on. There's a lot of activity in this space. So all of these areas that you see here, these are areas where we are seeing interest in using graph model technology. And the implications are really huge. The ability to predict what treatments will work best for a person based on this deep understanding of who they are, that's a game changer. And if we apply graph modeling on the operations side, it makes it a lot easier to really truly understand what's working and what's not working and why. So up until recently, the tech industry has been able to gather and use all this data without really a ton of oversight, which is obviously a problem. The healthcare industry is definitely a different story. There's a lot of fragmentation and rigidity when it comes to how the industry handles data. And that makes it really hard to apply graph models to health data. The problem's about to get even more complicated too, or it's already complicated, because we're in the middle of this big push to give consumers more direct control over their data. So both the tech industry and the healthcare industry up until now have largely operated on the assumption that the company owns and controls the data, not the consumer. But now these new regulations are forcing companies to rethink how they manage data. So all of a sudden, security settings aren't enough. You can't just put up a page and say, choose your permissions. They have to provide people with real control. And likewise, encrypted databases aren't enough. They have to think about where people live and where they have to store their data based on that. So everyone's trying to figure out how to handle these new regulations while still maintaining the value that graph modeling really provides. And here's where trusted data gets really, really powerful. So trusted data carries with it all of the security and context, as we talked about. So you can incorporate a trusted data or multiple pieces of trusted data into a graph model and create essentially a trusted graph. So we call these LifeGraphs. A life graph can include data that may be owned by lots of different people or companies, and the data doesn't even need to be located in the same place. So as an example, I own my health data and it's part of my life graph. My doctor is also part of my life graph. So her professional profile is also part of my life graph, even though I don't actually own that data. So trusted data is what really allows these graph models to operate within a new regulatory framework where data lives all over the globe, it's owned by all sorts of different entities, and it changes all the time. Trusted data allows graph models to incorporate that. The net is that ownership and control is going to shift from the company to the person, and privacy is enforced automatically within the system. So even if that data is being created by my doctor in an EMR or by my Fitbit device, the ownership of that data doesn't need to default to the company. It defaults to me. So we've covered trust and what it means to have trusted data and why it's so foundational in terms of bridging the gap between these new intelligent graph models and privacy. But the other really important element to creating trusted systems is how portable the data is. So think of how many things in healthcare require some form of data sharing. It's pretty much everything. And think about how many of those processes involve someone manually looking up the data or double checking to make sure that the data is right. The amount of overhead involved with health data sharing is staggering, and it's all because we're missing that trust layer. So how do we bring in that trust into data sharing? There's really 3 different factors to consider in how you build trusted data sharing and trusted data exchange systems. The first is how you configure the network itself. The second is how you're managing consent and governance, which is essentially the set of rules around how data is allowed to be shared. And the third is how you're packaging up that data so that it can be read and trusted by other systems. So let's talk about the network first. This is a pretty typical setup in the hardware, in the healthcare space. You have EMR systems, rev cycle management systems, analytics. They all have their own databases. Maybe there's a data warehouse thrown in the mix somewhere. And then there's all these external integrations with HIEs, vendors, reporting systems, on and on and on and on. These kinds of networks are really difficult to manage because each of these endpoints has a different type of data that may not communicate very well with the other parts of the network. So in addition to maintaining all of these actual connections, you have to enforce a bunch of interoperability standards, and you have to manage data governance for each of these connections. And then there's another problem with these types of networks, and that's data consistency. There's no source of truth that allows each endpoint to know what data is the right data. So if 2 systems, if 2 endpoints are storing my name, but one of them is misspelled, there's no way for the system to know which version is actually correct. And there's one more really major catch, and that's every time an endpoint shares data with another endpoint, they're moving data into a database that they don't control. And so every time they do that, they lose that data or they lose control of that data. So that puts us back into the situation that we were talking with at the beginning, where you're being forced to trust the entity that controls the data instead of trusting the data itself. So one way to address those spaghetti networks has been to create more of a hub and spoke kind of model. So this definitely simplifies things in terms of network management, but again, you run into the same issue as before. If you don't control the hub, then you don't control the data that you're sharing with the hub. And that puts us back in the position of needing to trust the entity that controls the hub. The other challenge with these centralized models is when you're trying to use them for analytics and AI. So typically, a hub and spoke model will force data into a certain standard to make the system easier to manage. But when you do that, you run the risk of losing some specificity in the data. So let's say, for example, I might have one EMR in my system that captures 5 different gender definitions, and another EMR in my system that only captures 2 definitions. If you standardize the system to 2 genders, because it's the common denominator, you really limit the potential of that data from a research and analytics perspective. By applying that 2-gender standard to the hub, you've lost the ability to do things like, if I wanted to study healthcare inequity for non-conforming genders, I would have no ability to do that because that granularity is gone. So trusted data networks solve both of these problems. The core principle of a trusted data network is that each participating entity, whether it's an organization or a person, is able to use trusted data as a way of sharing data without losing control of it. The data can be shared and moved around, but because the access rights are built into the data itself, the owner can revoke access, and that will be enforced even if the data has been moved someplace else. The other key principle of a trusted data network is governance. There are a few different ways that governance can be managed in a trusted data network, and how you set it up really depends on what you're trying to do. So one way is to use a neutral governing body that sets and maintains the governance model so that data sharing between participants always follows that governance model. One other way would be to have a subset of your participating entities really act as kind of a governing board. And then the last way is really the most democratic way, and that would be to have every single participant in your network contribute collectively to the common governance model. There's another nuance here that you can see, which is that there are probably going to be multiple layers of governance, especially when the network is handling personal data. So we call that multi-layered governance, and it's always going to be an issue with an identity and health data because of how consent is regulated. If you are treating all of these different layers as separate things, and you have a consent management solution and a data governance solution and a regulatory compliance solution, your system is going to get really bogged down. So it's important to see all of these layers as pieces of a puzzle. All these layers have to work together to manage how data is allowed to be shared on a network. And they all have to be flexible enough so that when people revoke consent or regulations change, the network can adapt to those changes without having to rebuild the entire model. I mentioned before the challenges about spaghetti networks and hub and spokes and the challenges that they have around data standardization and how that impacts AI and analytics. There's a few different ways to address this, but the most important thing here is to have flexibility in terms of how your network is set up. So we use a flexible schema model, and that means that standards can be applied in a more dynamic way. So I can store my data with all 5 genders, and when I present that data to a 2-gender EMR, I can apply a 2-gender standard. When I present that data to an analytics tool, I present all 5 genders. When you're trying to connect hundreds of different applications together that all use different types of standards, that kind of flexibility makes things a lot easier to manage. So now I want to talk a little bit about the implications of all of this. How does all of this translate into what you actually do in real life? So we work with companies building all sorts of cool stuff. But I'm going to highlight a few examples that really take advantage of trusted data, LifeGraphs, and these new network models. So I mentioned value-based care earlier. This is an area that really brings all of these concepts together. So both payers and providers are trying to figure out how to optimize these value-based care plans. And one of the biggest issues is lack of data. Providers want to understand more about a person so that they can choose treatments that will have the best outcome based on each person's unique needs. They're also trying to compensate providers based on a more nuanced definition of what quality actually looks like. So payers, on the other hand, are trying to understand how to optimize their coverage options based on this deeper view of what would work best for each individual person. They have lots of claims data, but they struggle to get a hold of clinical and demographic data that would help them do this kind of analysis. And people are often really hesitant to give their insurance company more information, and rightfully so. They're worried that it's going to be used against them. In both cases, there's an opportunity to use trusted data, LifeGraphs, and consent and governance to make value-based care and value-based contracting much better, both for people and for the industry. The second area I want to touch on is really an extension of how you use LifeGraph to manage identity. So we talked about how LifeGraphs can incorporate really any kind of data. If I'm a doctor, my LifeGraph might include my medical degree, my license, my verifications, my CE credits. All of that trusted data is going to get packaged up and presented into things like provider directories, which then gets used for scheduling and referral systems, populating into EMR systems, all sorts of other things. If I'm a patient, my LifeGraph might include immunizations, Fitbit data, my credit score, something else. I don't really want anybody to know my credit score, so that stays private until I apply for a loan, and then I can provide a very limited consent just to execute that loan. But my immunization status needs to be reported to the state registry. So the system packages up my immunization status as a trusted data, a piece of trusted data, and adds it to the registry. Then if I move out of state, I can revoke that registry's access, or the system revokes it automatically, and automatically add that same trusted data to the registry in my new state. In both cases, the system is using trusted data and LifeGraphs and consent and governance and these trusted data networks to build a more efficient system with better automation and deeper knowledge of how all of these different processes need to work together and who needs to see what information. And it does it in a way that makes personal privacy and ownership the cornerstone of the system instead of an afterthought. The same technology provides a framework for a lot of these next generation data systems where you're dealing with massive amounts of really highly sensitive data. So HIEs are a great example of this. We talked about registries, but we start moving into things like identity networks and even some of the really cutting edge stuff around digital self and ambient twins. But the last one I want to highlight is a little more immediate. I mentioned at the beginning some of the hiccups with vaccine administration. Vaccination sites have been, we've heard reports of them running out of cards. Cards are being forged. Inventory is being wasted because people don't show up for their appointment. People are struggling to figure out how to make an appointment. These programs have a lot of moving parts. You have to coordinate between multiple different distributors and providers and insurers and public health agencies. It's really hard to make it all work seamlessly. So I wanted to bring in Rob Lubeck, BurstIQ's Chief Growth Officer, to talk a little bit more about how these concepts we've been talking about are being applied to vaccine administration.
Hello, everyone. Nice to
Rob.
see you.
So Rob, I wanted to talk a little bit about what you're doing on the vaccine side. I know you're working with a couple of really key partners to take a lot of the capabilities that we've been talking about and build them into a solution for managing COVID testing and vaccine administration. So could you start by just giving us kind of the high level about what that solution looks like?
Absolutely. So we've seen so many problems out there, from the scheduling to the inventory management. So we have come up with a full end-to-end solution that's really modularized and plug and play. So it starts on the patient side. It includes a scheduling app, a reminder app. They can adverse drug reporting on there. There's a telemedicine if they get a positive test and they want to talk to a doctor immediately. And then there's also a COVID passport. So there'll be a digital record that they either got a positive or negative test, or they got the vaccines and when. And then on the provider side, everything from the back-end scheduling and site selection to a whole inventory management. Every vaccine is different of how it needs to be handled and how it needs to be thawed and how long it can stay out before it gets destroyed. So it tracks all that kind of end-to-end as well. And then there's also an event, real-time kind of for recalls on both the diluents and the vaccines. And then a command center analytics, so the provider can see at a glance who's getting what, if there's any issues, if there's any scheduling issues. So full visibility in kind of the whole spectrum. And then the blockchain, the platform, really connects all those data elements to become a single source of truth. So we know it's one source of truth. We know who the patient is. There's no issues about matching and identifying and everything else. And then that can also then integrate with state registries or EMR systems, whatever else needs to be for full integration.
So I'm really curious about how you guys are actually using trusted data as part of that. Like, so what does trusted data actually look like in that context?
So the trusted data also is in kind of an end-to-end solution. So we know who the provider is that actually administered the vaccine or did the test. We know which vaccine was used. So if there's ever a recall, we know that. We know where they got the vaccine administered. We know which arm they got the vaccine administered. Which kind of test, whether it's a PCR or an antigen test. And so really, if this becomes, so the patient's at the center and all these things connect to the patient. So we have one center source of truth, and then all the little arms are connected to that patient to ensure that that data is all trusted and reliable.
So is that the life graph then? Is that what a life graph looks like?
It is, and that's one part of that patient's life graph. So once again, if they get a test, that test gets added to their life graph. If they get a vaccine, then that COVID passport and that vaccine gets added to their life graph, and then just adds another piece of that health profile to the whole puzzle of that patient.
Mm-hmm. But it sounds like it also moves beyond that too, because you guys are using life graphs, both for the patient and the patient's experience and all the data related to them. But there's also a lot of vaccines that are going through their own, like they have their own life too, right?
Correct. So yeah, it connects the life graphs of the vaccines to the patient, but it might not just be COVID. It can be any other diseases or any other vaccinations. And then we're also need to track when the variants come out and the boosters and how long, we don't even know how long these vaccines are lasting. So once we all know that information, that gets added to the person's life graph. So they know when they need to get a booster or a new vaccine, et cetera. Go ahead.
No, go ahead.
And then it also extends out how to manage any kind of medical distribution chain, from getting that drug from the manufacturer all the way to the recipient. And then as top of everybody's mind is this whole kind of immune status, which is really an inherent part of that person's identity, which is also then an inherent part of their person's life graph.
Mm-hmm. And what happens to that immunity status? Like, where does that go? I mean, we talked a little bit about registries. Are they a part of this mix, and how are they a part of this mix? How does that live and breathe?
So we have that attested data. We know when that person either got a negative or positive test. We also know when they got the vaccine, and we store that data. We know, because we connected all the pieces, we know that's attested verifiable data.
Mm-hmm.
They could use, part of the app is they can show a QR code and they can get that scan to show that they do have a pass. We can also integrate with other systems and airlines or events or even other COVID passports, and they can integrate with our system, and then they use our information as the verifiable information source of truth.
Got it. So that makes a lot of sense. So what's next? Like, what's the evolution of this? Where does it all go?
It can go in so many different directions. I mean, it's really anything in the whole medical world or the identity world can fall in this life graph. Today is COVID. We don't know what's going to be next. And so, the future is so unknown of where it's going to go. And that's the nice thing about having this, is that the platform is really future-proof. So it can be used for any type of vaccine, any type of medication, any type of clinical trial, and everything in between. But once again, it's going back and we're building these life graphs. They're just going to grow and grow over time as more information is added to it.
Mm-hmm. And then become, they're in the hands of people. People really own that, and it becomes kind of something that you have control over, right?
Yes. And so in essence, everybody else owns people's data right now, including the Facebook and the doctors, and the power goes back in the patient's hands, and even a way potentially to monetize. I mean, so much research is done on patients' data outside of the patients even knowing what's going on, because they umbrella consent to all their data being used for whatever. And so hopefully in the future that some of that monetization come back actually to the patient, they can get compensated for the use of their own data versus other companies getting compensated.
Yeah, no, that totally makes sense. And especially, I mean, I hate to sort of, be a little bit doomsday, but we've heard a lot that this is really kind of the practice run. Like, pandemics will continue to happen. This isn't going to be the end. And so the more we can prepare, the more we can start to understand how to do this right, the better off we'll really be. And there's a lot of broader implications to all of this. It's really clear that our immunization status and our health and our identity, they aren't kind of really separate things. They're all pieces of who we are. They're all pieces of our puzzle. And to me, that's actually kind of the most exciting part about all of this, is that the ability to connect all these things together and really gain this deeper understanding of what works and what doesn't, and to be able to do all of that while truly honoring each person's rights and their privacy. To me, that's amazing.
It is. It's definitely the future, and we are just excited just to be able to build that future together.
Yeah, awesome. So Frank, I know that you've been keeping an eye on the chat to see if we have any questions. So I want to toss it back to you and see if there's any questions, or if you have any questions, or the audience has questions, either for me or Rob before we finish up.
I have a few, so let's kind of take them one at a time. And we've been talking about this whole aspect of individuals being able to build their life graphs, and I know you hit on this throughout the presentation, But let's take a step back and let's talk about privacy for a second, because we're running headlong into this notion of having to have proof of a vaccination or a negative test to travel or for other parts of our economies to open. And while we might say, hey, you still have free will, you don't have to take a vaccine. But if I need a vaccine to get into, to get on an airplane, or a test to get on an airplane, is it really voluntary? And how do we really protect the privacy of individuals as health crosses over to commerce now? Can you dive a little bit deeper into that aspect of it?
Yeah, so it's really interesting. I think as we start to see people directly owning and controlling their information, I think we're really going to see this shift in where the leverage actually sits and how economies are actually functioning. Right now, data is enormously valuable and enormously powerful, and we're really in this paradigm where whoever controls that data, really has a lot of leverage and power in the market and in the economy. As we start to see this shift towards people actually owning and controlling that data, the commerce of that is going to shift pretty dramatically. And you're really going to start to see people leverage their own data to really extract value that benefits them more directly. And so economies are really going to start to transform and become much more consumer-centric, much more person-centric, and all the value that's extracted from that data is going to be extracted by the person who owns it and controls it, as opposed to it being really consolidated in these, few large major technical players or tech players.
So if all this data, let's say, is stored on BurstIQ, or BurstIQ, the platform has access to all this data, what makes BurstIQ different than the Facebooks of the world? Are you just going to be another Facebook? Are we going to be another Facebook? Why are we different? What is kind of the under the covers things that really helps this become a reality?
Yeah, so that's a really good question. So the way that BurstIQ works is we provide the infrastructure for all of this data to live and breathe and be wrapped up in this trust layer and be exchanged really securely. All of that infrastructure is what BurstIQ packages up and makes available. The actual data itself, the ownership of that data, is 100% attributable to the owner. So we have no access to that data unless somebody actually gives us access to it. We provide all the tools, all the frameworks to make that possible, but we're not the holder of the data. We're not the owner of the data, and we have no rights to it. And that's exactly the way it should be.
Well, I love that answer. I have one for Rob now. So Rob, there's been a lot of press around the problems in this vaccination administration rollout. I mean, you hit a couple of them, but I think a lot of it centers around this whole concept of scheduling. Why has that been such a problem in these early stage rollouts?
It's a great question, Frank. And I think there's a few different things that have created problems around scheduling. I think number one, I think they weren't ready to handle the capacity and influx of people trying to schedule the vaccines altogether. We were very diligent in making sure that we had enough capability and bandwidth and performance to handle whatever the influx of simultaneous schedules could be. And I think there was also some miscommunications even from the jurisdictions themselves and how they were handling the different phases of people being allowed to do the vaccine. And we heard a lot of instances where people were kind of doing backdoors and breaking into the scheduling system so they could schedule the vaccines because it would bypass their criteria to be eligible for the vaccine. And so it's really a capacity and really kind of locking down the system to make sure people go down the right path. Number one, make sure they're eligible, and then verify that, and then if they are verified, allow them to schedule the vaccine for when they're able to. And those are the two of the biggest issues that we saw in the marketplace with some of the solutions out there.
Yeah, I mean, it sounds simpler than what it actually is in implementation in terms of when you have these specialized categories of eligibility and how people represent themselves, which is half of the problem as well. It's been nice to see that our solution with our partners have been able to address this very early on and provide a scalable solution to manage that. So thank you for your work. I want to go back and digress just one more real quick. Amber, I want to talk a little bit about the concept of trusted data, just a little more versus the converse. What the converse being creating common schemas or taxonomies, and why is this approach of building intelligence in the data about what the data is, so the data actually knows what it is? Why is that so revolutionary versus, hey, can't we just all standardize on, hey, it's Moderna shot 1?
Yeah, the interesting thing is that standards, there's a lot of standards out there for a lot of different types of data. And I think, there's a general consensus that we are never going to be able to settle on just a single standard that kind of applies to everything. It's just never going to be able to happen because there's so much variability in types of data and how data needs to be used, how data needs to be presented. It just kind of ranges all over the place depending on what the data is and what you need to do with it. So what trusted data really does, because it brings together all of the context of that data, so things like what's the history of that data? Has it evolved or changed over time? Has it been verified by somebody? All of that context of that data provides you in that data itself with all of the tools that you need in order to apply whatever standard you're trying to apply. And so it creates this flexibility, not at a system level or even, a network or even at a file level, but it creates this flexibility within the data itself. And that's really powerful because it means that whatever system you're trying to use that data in, the data can adapt itself to fit the needs of whatever that use case is. It creates this inherent flexibility because the data knows itself, understands itself, and because all of its context and intelligence is built right into it.
That's huge. That's huge. Working with, large, big data for a long time, and even call it micro data sets and micro analytics. The biggest problem is putting data in context for these systems to consume and use. Both from an understanding as well as a permission status to use them, and how it relates to each other, which is very important. And so much information is really contained, particularly in healthcare and unstructured data, and being able to harness that is a huge breakthrough.
Yeah. Well, I was going to say the interesting thing about that is that when you then combine that flexibility in the data itself and you start to bring that together with the flexibility that we were talking about in terms of how you manage consent and governance, the two of those things combined have this incredible power for how you create systems that you don't have to be fixed to a certain standard. You don't have to be fixed to a certain network configuration. You don't have to be fixed to this certain set of data that's allowed to operate within your system. All of those things become much more flexible because you really have all the components for what data behaves and how it can behave differently and how it can adapt itself and how the governance models can really control and manage all of that different complexity in this much more fluid way.
I have one question. One new question I want to kick out to you from our audience, and this is from Christian. Thanks, Christian. What incentive is there for current centralized data owners to open up their silos? Will it have to be policy that coerces them? And I'm just going to, are there other means? And I would love both of you to take a crack at that question.
Yeah, that's a really good question. I think fundamentally what it's going to boil down to is the business need. Centralized systems are pretty limited in terms of what they can do, especially when you start to get into AI and intelligence and building out new service lines that really require that. Those legacy centralized systems just aren't structured to be able to handle these kind of new models of bringing together data and the fluidity and flexibility that's required in how you manage that data and connect it and build all these dynamic relationships. They're just not set up for that. And so as businesses start to see, I need to create a new process, I need to be able to do this in a more automated way. I need to be able to get deeper into my data and bring in new kinds of data. And I need to be able to do all of that under these new, more flexible and evolving governance frameworks. Those systems just aren't set up for it. And so the incentive is really truly going to just be a business incentive. I can't get to where I need to go if I maintain the existing system.
You want to add anything to that, Rob?
Yeah, that's a great answer. In addition to what Amber just said, I think there's a couple of things at play that are creating this world. Also, there is some policy going on. The CARES Act is requiring companies to start allowing access and portability of the client's data, which is helping the fact. And as we get this new push of these digital front doors and patients and people requiring more and more access to their data, I think that's also pushing these companies to figure out solutions to enable some of these, just to make the sharing a more open space.
I'll add one comment, even as a host, so I could do that occasionally. I think we're fast approaching a tipping point of data scarcity to data abundance. And when we get in this notion of data abundance, yes, data itself does have value, and there'll be policy and regulatory guidance that we'll need to push, freeing up some of this for individuals. But we also see data just emerging from so many different perspectives that there's no one real entity that has access to all of it. So back to what both Rob and Amber were talking about, to be able to combine data from different ownership positions to give a broader understanding of, say, a particular encounter is going to really drive the need for a lot of this to mature over time. And still looking, we work a lot with government entities on the policy side and have been really strong advocates of pushing forward on individual data ownership and liberties. Okay, so I think that's pretty much wrapping up our time for the day. I want to plug the next Knowledge Burst webinar. We'll be sending out a note when we finalize the date, but it's smart data, smarter AIs. We're gonna pick up on this whole concept of smart and trusted data objects and what that means in the broader context of the evolution of artificial intelligence from all its dimensions, and how it will drive really a whole new level of artificial intelligence. And really, we're going to start with a foundational premise. What is AI really? It's such a broad term. It's got so many connotations to it, from all the folks that talk about it, taking over the world, to really solving so many of our day in and day out problems. And I think there's really an answer that falls in between, where machine learning is going to become a powerful tool in our day-to-day lives. So look forward to this next webinar. I look forward to seeing you all in roughly a month. And until then, feel free to reach out to us anytime, or connect with any one of us on LinkedIn. Really appreciate you spending the time with us this afternoon, and have a great day.